Engineered plastics offer tremendous advantages over traditional materials like metals in bearing and wear applications. These applications include bearings, bushings, gears, wear pads, rollers, to name just a few. These can offer lubrication-free alternatives, which can offer prolonged wear life and lead to overall increased system efficiencies and cost savings. Of course, choosing the right plastic material is critical. Two factors that must be considered when designing a plastic wear component include the pressure the component will see and the velocity, or the speed, of the contact surfaces. The result of pressure and velocity combined on a plastic surface equates to frictional heat. The more pressure and or the more velocity, the higher the frictional heat on your bearing surface. And plastics can fail with too much heat. So knowing the PV of your application and picking the right plastic is critical to your success. So, how much heat can a plastic bearing handle? You'll want to refer to a physical property called the limiting PV of a polymer. Knowing the limiting PV of a plastic material will allow you to run a simple calculation to see if your application is safe for a given plastic. You simply need to multiply the pressure in pounds per square inch times the velocity in feet per minute for your application, and this will yield your PV requirement. For example, a bearing surface with a load of 100 psi and with a shaft speed of 40 feet per minute will yield a PV condition of 4,000 psi feet per minute. So, you must use a polymer with a limiting PV of at least 4,000. Here is a list of some common materials and their typical limiting PV values. While plastics are inherently self-lubricating, many are available today enhanced with an internal lubricant additive. These additives can include oil, maybe a mineral like mica or graphite, or even PTFE. These lubricants are designed to coat the mating surface as the polymer wears, thus reducing the coefficient of friction, reducing the frictional heat, and thus leading to longer wear life. In the previous example, a standard nylon may not be sufficient for a 4,000 PV application. However, a nylon enhanced with an internal oil lubricant can provide just the extra slickness needed to handle the additional frictional heat. When considering the PV of your application, oftentimes the velocity of a rotational bearing is given in RPMs, or revolutions per minute. A simple calculation using the shaft diameter can be performed to convert RPM into feet per minute. If you need any help at all calculating the pressure velocity condition of your bearing surface, or if you need any help navigating the best polymer material for your application, reach out. Not all material data sheets identify the limiting PV of a material. However, Boedeker.com has many stock-shaped material data sheets with this PV data. You can also reach out and contact us for a list of common materials and their limiting PV values, along with other important bearing and wear data to enable you to make the best material selection decision. Boedeker Plastics has a technical team ready to support you. Please feel free to add your comments below, like and share this video if you found it helpful, and subscribe to our YouTube channel. Thanks for watching.